So we're going to be going over the study guide for lessons 10.1 to 10.4. We'll look at each page here and we'll go through each problem. So I'll be going back and forth to each page here. So the first problem, if you see, it tells us that CB, which is the radius, is 2. So then we need to use that to find DF, which is the diameter. So the radius is half the diameter, so DF, or the diameter, should be 4. Number 2, you need to find the circumference. You need to use either circumference formula, 2 pi r or pi d. Notice that it gives you 2 out of the 3 sides of a right triangle, so we're going to need to use the Pythagorean theorem to find the third side, and the third side of that triangle is going to be the diameter. So we're going to multiply that by pi and find our circumference. So we have 3 squared plus 4 squared equals c squared, and this will tell us what the diameter is. So 25 equals c squared, and c would be 5. So the diameter is 5. If we use the circumference formula, that's pi times diameter. So we're going to multiply 5 times pi. It asks us to round to the nearest hundredth. So we're going to get 15.7, which doesn't really need to be rounded to the nearest hundredth, so that would be our final answer. Now number 3 says circle V has diameters UX and TW. We need to find the arc measure of TU. If you have 2 diameters that are intersecting each other, that means you have 2 lines that are intersecting each other, which will make 2 sets of vertical angles, or 4 vertical angles. We know that vertical angles are equal, so we're going to put the 2x plus 10 here equal to x plus 60. That will give us x. So we get 2x equals x plus 50. So x would be 50. If we plug that into either one of those, that gives us 2 times 50 plus 10, or 100 plus 10. So each of those arcs are 110 degrees. That means we have 2 that are 110 degrees. We know that all 4 have to add up to 360. The other 2 are a set of vertical angles, so they're also equal. So we can put it together to look like this: 110 plus 110 plus x equals 360. And the x value will be our answer. So we have 220 plus 2x equals 360. So we have 2x equals 140. So x would be 70. And that gives us the measure of the arc. The next, we have a clock that they're talking about. So if you draw a clock, it says its diameter is 8, and then the hands of the clock, we need to find the arc formed where the hands go from noon to 5. So if I draw this out, the diameter is 8. And if I split it into sections for the hours, it's a little bit uneven, but you can kind of get the point. These are our hours. What it's asking us to find is the arc that's formed from noon to 5. So if we think about a circle having 360 degrees in it, if we divide that by 12, that gives us what each hour represents, which is 30 degrees. So we need to add up each section from noon to 5 to get our arc measure, which is going to be 150, because you have 30 times 5. So all this is giving us the parts of the length proportion for finding the arc length, which is L over 2 pi r equals x degrees over 360. So I'll rewrite that again here. Now the arc measure that we found is going to go in for x degrees, so that's 150 degrees. L is what we're finding, and then we know our diameter is 8, so our radius has to be 4. So if we plug all that in, we're going to solve for L by cross multiplying. So we get 150 times 8, which is 1200, times pi, we'll just leave it in terms of pi, equals 360 times L, and we're going to divide each side by 360. So 1200 times pi gives us 3768. Divide that by 360, and that's going to give us L. We need to round to the nearest hundredth, so that's about 10.47. So the answer here is 10.47. The next one, we're asked to find the circumference of circle X to the nearest hundredth. This is probably going to be a bonus on your quiz, as we didn't really learn about right triangles and special right triangles in detail. So this is considered a special right triangle. We have two kinds, either a 45-45-90 triangle or a 30-60-90 triangle, which I'm talking about the angles measures. So this is a 30-60-90 triangle. If I label the triangle, and it's a 30-60-90 triangle, the shorter leg is going to be x, the longer leg is x times the square root of 3, and the hypotenuse is always 2x. So if we go back to our triangle, we have that the longer leg is 2 times the square root of 3. Well, if we know that, we can label it. It's going to be across from the 60. So this is 2 square root 3, and if we go backwards here, we can get each other side. So this would have to be 2, and this would have to be 4. Now what that tells us is, if we find the 4, which is the hypotenuse, it's also the diameter here. So to find the circumference of a circle, we use pi times diameter, or in this case, pi times 4, which is going to be about 12.56. And that gives us our circumference. Which is letter C. Number 6, we are given that the two chords are equal, which makes their two arcs equal. It gives us part of the arc, and we have our radiuses intersecting or bisecting the chords, which splits those in half. So if the whole arc, or I'm sorry, if half the arc is 25, the whole arc TU would be 50. And if we're asked to find VS, that's the other side, the other arc, and those are going to be equal since the chords are equal. So VS would also be 50. Then we have number 7 is probably best to draw. It says we have a 22-inch chord 6 inches from the center. We have to figure out the radius. So 22-inch chord, 6 inches from the center. If we make this a right triangle, that's going to give us our radius, which is here, and that also is considered the hypotenuse of the right triangle. Now if the entire thing is 22, the entire chord is 22, that means each section is 11 because it's split in half by the radius. So that makes this side 11, this side 6. We need to find R. So we have 6 squared plus 11 squared equals C squared. And that's going to give us 157. So we need the square root of 157. Which is about 12.53. So that gives us a radius of 12.53. We could round that to about 13, but that would be our answer. The next one, number 8, is related to a theorem where if you have two intercepting arcs, or two angles that are intercepting the same arc, they're congruent. So if one angle here is 28, the y would be 28. And then we have number 9, which is a triangle is inscribed in a semicircle, and there's also a theorem for this. If a triangle is inscribed in a semicircle, it's considered a right triangle. So if one of the angles is 40, we know one of them has to be 90, and then that would leave us, if we know that all three angles have to be 180, that would leave us with 50. So it's asking for 2 out of the 3 angles not given to us. That would have to be 90 and 50. And the last question, it says an equilateral triangle is inscribed in a circle. Right here, what is the measure of the arc that one of the angles intercepts? Well, if we draw it out, we have a triangle that's equilateral inscribed in the circle. That makes each angle 60. So it's asking us, what is the measure of the arc that one of the angles intercepts? Well, all of the angles are the same, so the arc is going to have to be double the angle, which is 120. And that concludes our study guide.